All right. Good morning, everyone. Thank you so much for being here. It's amazing to see a room filled with women in tech and a small group of guys over here. Welcome, guys. Thanks, everybody, for being here, and welcome to the second annual New York City ACM celebration of women in computing. I'm Jessica Lawrence Quinn, the CEO of New York Tech Alliance. We are the organizers of this event, and we are also a nonprofit organization working to build a more inclusive, empathetic, and civically engaged tech industry here in New York. And I'm so happy to see you all here, in particular because I started my career at the Girl Scouts, and I worked there for a number of years. And one of the things that I did while I worked there was start STEM programs for girls and encouraging young girls 5, 6, 7, 8 years old to get into science, tech, engineering, computer science. And so it's amazing to see all of you here. You are exactly where I hoped all of those young girls that I worked with would end up. So thank you so much for being here. You're in for a real treat today. We have some great speakers, some great workshops, and I think you're really going to benefit from getting to know each other as well. We have over 200 people registered from colleges and universities throughout the city and surrounding area. So definitely take some time during our lunch breaks and snack breaks and everything to get to know each other and to network. So I want to start by thanking our sponsors. We are very lucky to be in this space today. So thank you to Google for hosting us and for providing our meals. It's amazing to be inside such an outstanding tech company as the host for this space or for this event today. So a special thanks to Grace, Anna, and Elizabeth for all of their work in helping us put this event together. And we have a few other sponsors for today as well. Let's see if we have a slide. Let me go back. So ACMW, obviously supporting this event. This is part of their National Women in Computing event series, Microsoft and Verizon. So thank you to all of our sponsors for making this day possible. And as I mentioned, we have a very full day for you, lots of great workshops and speakers, opportunities to network over lunch. And so as we go through the day, you should each have a schedule on your seat, and I'll be coming back up to kind of direct you when we get into our breakout sessions. And let's see. Next, I want to thank, I don't think he's quite here yet, but New York Tech Alliance board member and CUNY professor Ted Brown for being such a champion of this event. And then I want to point out the members of the New York Tech Alliance team who helped make this event possible. Our leader of this event, the director of this event, Alice Ng, in the back. So if you need anything, Alice is back there. She put this whole event together. So thank you, Alice. Round of applause for Alice. Andy Saldana, our Director of Operations, also collaborated with Alice on this event. And Eric Grimmelman, our President. So thank you all.
There we go. My name is Alyssa. I'm an engineer here in New York. I work in search features, which is like all of the extra stuff that you get in search that is not the web results. So when you get like a box about Barack Obama with all the facts about him, or you search for movies and you get like a carousel of all the different movies and facts about them, stuff like that. What? SEO? Oh, no, I don't do that. Yeah, so go ahead.
And then I'm Julia. I work here in New York. I'm actually on the local search feature team, so one of the money features that Alyssa is a larger part of. But we handle local data in both Google search, like google.com, as well as Google Maps. My team is sort of doing a lot of that and integrating between the two.
Okay, she's not here.
All right, so we're going to start by doing a quick overview of what's expected of undergraduate CS majors when they're applying to Google and ways that you can be sure that you're sort of on track as you go through your undergrad degree. So freshman year, do we have any freshmen in the audience? Awesome. Thank you guys for coming. It's awesome that you're already so involved with computer science that you've joined a club and are here. So freshman year really is all that's expected is that you've taken, one CS, one math class, you're getting your feet wet, one language. So generally schools these days are teaching Python, Java, or C++. So if you're taking class at college, you're probably doing the right thing. Formal logic, if else, for loops, you know what you're doing. And then learning how to be your own independent coder. So reading code, trying to understand what it's doing, finding documentation to support you. I'm sure we've all been in class and someone says, oh, there might be a method to do this, and then you go look up the Java docs and figure it out. So taking the initiative, being able to sort of work on your own. Version control, if you're lucky, your school is actually using some form of version control and teaching you all about that. If not, don't worry, you'll interact with it soon. Debugging, again, if you've ever done a CS project, you know how to debug, or you've started learning. And then outside of the classroom, trying to get involved with projects. I'm sure that there are clubs, or you can find open source communities that would love help. So freshman year, generally the basics. Oh, yeah, I'll take this. Hey. So outside the classroom, this is true for all years, but especially as a freshman, it's time to start thinking about if any of these clubs are at your school, ways to get involved. So the first club that we're discussing here, ACM, I think you've all heard of, and luckily you found your way here. There are a whole list of others. Some are represented at some schools, some aren't. Hacking and programming competitions. I'm sure you guys have seen emails saying, yo, there's a hackathon, who wants to go with me? This is really great experience in terms of having great stories to tell during interviewers, having practical real life ways to use your coding skills, and they're really fun. So we've listed a few that are in the area because I think most of you guys go to school around here, so you might have seen these, might have participated. Has anyone been to Penn Apps? No? MHack? TreeHack? VT Hacks? All right, well, maybe you guys can find your way there in the future. Also, programming competitions. I know that Google actually has one that just started now. Do you even remember hearing about this? No, it's like an international competition where they like problems and progressively harder and harder. And the idea is you can do it on your own time. We don't need to actually fly or travel anywhere. You can just sort of tackle this problem on your own and submit your solutions. App development. Maybe you guys are lucky enough to have a club at your school that has resources and is building a mobile app. If you do, you should jump on it, get that experience. And then open source projects, we discussed this a little earlier, finding a project outside of the classroom. Google has a summer of code. The deadline is in 2 days, 3 days. So if you are at all interested in doing open source development this summer, you should take a quick look tonight and apply if you're interested. And then, here we go. Google Code Jam is the online competition that I was discussing earlier, where every day they'll give you a new problem, maybe not every day, but there's a series of sequentially harder problems that you can do and test your skills and have something to point to sort of prove that you're good at what you're doing. All right, sophomore year, basically a continuation. You are taking harder computer science classes. You are learning more about more advanced topics like data structures and algorithms. You are now proficient in your language of choice, and you're having experience doing other sorts of work beyond just your classroom. So yeah, finding open source, hackathons, whatever, just getting more experience beyond your classes. Junior year, multiple language proficiency, dun dun dun. Knowledge of more intense algorithms, big O. This is pretty standard if you're just taking your curriculum in your college. Operating systems, design knowledge, discrete math, these are generally things that you're going to get if you're getting a computer science major at most schools. But if not, if you see an opportunity to take a discrete math course, why not? Check it out. Might be useful. Okay, as a senior, do we have any seniors here? Okay. I actually missed it. And we have juniors too. A couple juniors and then sophomores. All right, so there is an even spread. So hopefully some of you guys have heard this and it's actually sticking. Senior year, you're proficient, you've got your languages. This point, industry level, software engineering, internships. This is pretty big. Junior year, you should be applying for an internship so that senior year, when you're actually applying for a real job, you can point and say, I was an intern, I have this experience. It really just puts you in a better position for actually getting your first real job, to be able to point to an internship you had and like skills and tools you worked with. Really awesome if you can get one. have a good resume. Google actually has great resume tips online. I'd highly recommend looking through them. They highlight explicitly what you should do for a technical resume instead of just a general, like, all-purpose resume. Because if you're applying to sort of some other industries, it might not be useful to say that you took an operating systems design class. Whereas if you're applying for a software engineering job, that is really useful. So remember to highlight any practical things. Interview prep, which we're going to talk about next. And then referrals. This is a great point that is maybe not obvious to people who don't already have friends in this industry, but referring is the best way to get hired by far. So if you have any friend or any graduate, any alum who happens to be working at a company that you're interested in working on, shoot them a message and ask if they would refer you. It bypasses a whole ton of boilerplate and really hard cutoffs that are, the numbers are crazy when you think about how many people are applying to these jobs online. So if you have anyone reach out to them. And it's not, don't be super embarrassed to ask. It's not like you're asking a huge favor of someone. It's the way things work these days. So highly recommend if you can. All right, preparing for technical interviews. This is a new part of the Google application process. Have any of you guys applied to Google? No. Yeah? Okay. So have you applied recently enough where you had this sample question? Okay, you might get one of these too. I'm not exactly sure which applicants are going to get sent this snapshot, but I know it's now pretty ubiquitous, and so you should be aware of what's going to happen. If you apply and you are sent a response saying, "Oh, thank you so much for your application," before you do a phone screen, we'd love for you to complete the snapshot, and the snapshot is, most importantly, a time for you to show your real programming skills in your own development environment. So the technical interview that I think you've all heard these myths about, it's you on a whiteboard or it's you in a Google Doc. You don't have your IDEs. You don't have the peace of mind to sort of sit down and really focus. This is going to be, it's a time limit. So it's an hour long, but you're given a question and you're on your own turf and you can just go for it. And it's a chance to really prove in a very comfortable way that you have this skill, and it's used in the hiring process down the line to determine if you're a great coder, because nerves always get in the way. So this is a chance to really show it. You're going to be given the question, and they give you a couple practice problems so that you can get a sense of what you're up against. And then the instant you click start, you have an hour. So don't start it in the line for lunch or something in a bad spot. No, give yourself some time and prep yourself. But be aware that this will come, and take it seriously as a bottom bullet point because it is a really strong data point. All right, I'm now going to pass it on.
Hi, so I am actually an interviewer here at Google, mostly on-site interviews, but sometimes phone interviews too. So I'm going to talk about what the interviews are actually like. So usually you'll start with a phone screen, and if that goes well, then you'll be invited for on-site interviews. And both of the phone and on-site interviews are about 45 minutes long. When you come on-site, usually you have 4 to 5 interviews in a day, so it's kind of a marathon. So each of these interviews follows the same format. First, there's a little introduction. This is where, we'll just introduce ourselves. We want you to be comfortable, ask if you need anything, and we might ask you some questions about your resume. So if you have a project on your resume, we might ask you about that project or previous job experience. Be prepared for questions like, what was a challenge that you faced on this project? Or what is the most interesting problem that you've worked on? Stuff like that. And then we'll have the technical part of the interview, which is the bulk of the interview. And this is where we'll give you one or more technical questions, and you have to work through the question either on a whiteboard or sometimes we have like a computer. There's a new environment where you can write code kind of thing. So this could be like one big question. Sometimes it's a question that's in parts. So like we'll give you the basic setup and it starts out easy and then we'll keep making it more challenging, that kind of thing. And then we leave 5 minutes at the end for you to ask the interviewer any questions because, the interview is always going both ways. Like, we're interviewing you, but it's also your chance to interview us and figure out if this is a place that you want to work. So you've probably heard myths that we ask these questions like, why is a manhole cover round? And if you were an inch tall, how would you get out of a blender? We don't ask questions like that because it's not helpful. So the questions that you're going to get, there aren't going to be surprises. It's like coding questions, algorithms, stuff that you can prepare for. So the things that we're actually looking for are your coding ability. So like, how well do you know the language that you're writing in? Do you use common libraries? Can you write clean, easy to read code? Algorithms and data structures. Analytical skills, so that's kind of just like general problem solving. How do you approach the problem that we give you? And design, so is your solution clean? Can it be extended? Is it easy to debug? Stuff like that. So there's kind of categories of questions, and when you're here for on-sites and you have many different interviews, each one will try to target all of these. So throughout the course of the day, we'll focus on all of these. So coding questions, it's more focused around like, do you write clean, easy to read, bug-free code? So here's where we might look at, are you taking advantage of common things for your language? We might ask you questions about the language, like if you say you're really good at C++, we might ask like, what is a virtual function? And this is less focused on like the actual complicated algorithm, but we will look at algorithms too, probably in different interviews. So algorithms are really important. You'll get questions like how to sort something, how to search something. Pretty much always we're going to ask you at the end what the time and space complexity for your solution is, so you should definitely be able to analyze that. Data structures are really important, some kind of basic math, and operating systems. That's like less common as an interview question, but I guess it's still good to know. If you took a class, you'll probably be fine.
I would love to add quickly, when we talk about algorithms, it's less likely that they're going to say implement, a reverse sort of this heap. You're not going to get like a test question where it's a well-known algorithm, you have to just implement it. Generally, it's take something that's well-known but apply it in a certain case.
Yeah, exactly. It's not like we expect you to just have all of these common algorithms memorized and we're going to name one and then you could just reproduce it. That's not really the point. So it's going to be giving you a new problem and seeing how you can like apply or tweak algorithms that you have learned about for a new situation. Okay, so yeah, we just kind of talked about that. But for the algorithmic part of the problem, some really important tips are, first just listen to the problem carefully and ask a lot of questions. We expect you to ask questions. It's not like a bad sign if you're asking us questions. It's a good thing. We also don't expect you to, immediately get the perfect solution. It's much better to just say the first thing that you think of than to say nothing at all. So if you think of, something that you think might work, you should bring it up, talk about it, tell us why you think it might work, why it might not work, and then we can gradually improve upon it from there. And it's also really good to kind of talk about your approaches as you're thinking about them. So we like to see you say like, well, I'm thinking about this, here are the pros and the cons, I'm thinking about it this way, it might be better because blah, 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 because that's what you do in a real world scenario when you're facing a real problem working with a team. And finally, be paying attention to hints, because if you're having a hard time, your interviewer will probably give you a hint. And it's also okay to ask for a hint. If you're totally stuck, you can just say, I'm not really sure what to do. Do you have any tips? Do you have any hints? Do you have a suggestion? Okay, so communication is really important in these interviewers too, because when you're at Google, you're not going to be working in isolation. You're going to be working on a team. So it's really important that you can talk about technical problems and explain your thoughts in a way that other people can understand and like work with. So you should definitely talk as you're thinking things through. If you're not saying what you're thinking, then we have no idea what you're thinking. And it's hard for us to make any kind of judgment. So talk pretty much as you can. Drawing pictures is really helpful, especially at the beginning when you're trying to figure out like what the setup of the problem is, what a good solution might be, and it's really good for communicating ideas. If you do need some time to just sit and think about it, that's okay too, but you should just say like, I need to sit and think about this for a second, do your thinking, and then say, well, I think blah, blah, blah. Just one thing to not do is like sit totally in silence and then start writing code without saying much. That's not the right way to do it.
I would add also, especially on phone interviews, when you can't see the other person's face, it's really important to say, I'm going to take 2 minutes. If it's quiet, don't be worried. I'm just thinking.
Yeah, absolutely. Yeah, and then the second point here is that, the interviewers, we want you to succeed. We're not there to cause trouble for you. So it should be like a discussion, not a test. You should feel free to talk to us about stuff. Sometimes the interviewee could bring up a point that I never even thought of, and that's really cool. Sometimes, they come up with a solution that isn't what I had in mind. And it's really fun if we can like get a good discussion going about that. It's a really good signal. Cool. So before your interviews, you should just review all the common algorithms, data structures, practice, practice, practice. So when I was prepping for my technical interviews, I just did tons of practice problems from like Cracking the Coding Interview is a really popular book. They have good questions. You can find stuff online. And practicing with friends is really good too, because the way that you're going to do an interview is it's different from just, doing a homework assignment. You have to write code up on a board in front of people, and it's kind of scary. So I found it really helpful to like get a group of friends, and we would take turns giving each other a question and doing it in front of everyone, because, it's terrifying at first, but it gets better the more you do it.
It's also really valuable when you're on the other side. So you're the person asking the question and your friend is going through the steps. You can realize, wow, it's really confusing if they don't explain their thought process first. I have no idea why they're doing this. So you learn how to be a better interviewee when you're the interviewer.
Yeah, that's a great point. So also, you generally can pick what language you're going to be doing your interview in. So whatever language you're choosing, make sure you know that language really well. Know like features about that language, know really common functions, common libraries, that kind of thing. Because if you say that like I know this language, then your interviewer will expect you to be able to write working code in that language, not pseudocode.
Also to this point, maybe you took your first year of classes in one language and then your school switches you up for the next year. This is pretty common actually. Your most comfortable language might be the first one, but if all last semester you were writing in a different language, you should think very carefully before you do your interview which one you'd rather do. And if you go back to the original language, study up on it the night before. Make sure you can write something that compiles. That's a gotcha that I've actually noticed, because schools like to teach you more than one thing, but that means that you're less fresh.
Yeah, so basically, like pick what language you want to do and then do lots of practice interview questions in that language and make sure you can write real code. And if you know anyone who's been through the process, it's useful to talk to them too and find out what their experience was like, because it's different for everyone.
Yeah.
Cool. So what the interviewer is thinking while all of this is happening, a lot of it is just how did you approach the problem? How do you think about solving it? it's really important to test edge cases. So you should always talk about it. Like, I think the edge cases would be this, this, and this. We want to know that that's something that you thought about. Yeah, so we're just looking for like a lot of the core concepts, whatever algorithm is being used, the complexity analysis, as we said before. And then also testing is really good. So you should always, once you're pretty sure you have a solution, suggest a test case for it and actually go through all of your code and make sure it works. It's always, like, personally, I think it's not a good sign if I have to say, like, can you test this for me? It's better if you can proactively say, like, I think this is right, let's try it. So you should, like, your goal is to prove to me that your code works.
I remember there was one interview where this was, I think, a phone interview, so there was no facial contact. But I said, yeah, so I'm pretty sure that this function is going to do what you want. And there was some silence. Are you sure about that? I was like, let me test it. But didn't get another round. Really, it's because the silent, like, are you sure that this is working? Is you never want to hear that.
Yeah, so like how clean the code is also important because as the interviewer, we need to be able to follow your code and understand it. Otherwise, it's hard for us to figure out if it's actually working or not. And also, in a real world working environment, we would want you to be writing good code too. So that's something that we care about and are also evaluating. And how, we kind of talked about this before, but communication is important. So phone interviews, like she said, probably the most important difference for phone interviews is that we can't see you, so it's extra important to talk, to say what you're thinking. So for phone interviews, it's usually like a less involved question. It's more often many small questions just because it's a lot harder for the interviewer to get signals when it's not face-to-face. But when you're writing code in a Google Doc, some like little tips, just make sure you're indenting your code, formatting it so it's easy for us to read, make it clean. Have your phone charged. You don't want your phone to die in the middle of your interview. That'd be bad. It'd be okay, probably, but use a headset if you can. It's really awkward to like hold a phone and try to type at the same time. Find a quiet place. Make sure you have like good internet access because you're probably going to be on a shared dock with your interviewer. Have some pen and paper nearby because it's usually helpful, or it's often helpful to like draw pictures. So make sure you have everything that you might need there ready before you make the phone call. Cool. So,
well, do we have any questions about anything we've said so far? Okay,
cool.
Yes.
I would say it varies. Very occasionally, you'll get hired like for a specific, sometimes you'll get hired for a specific thing. Like if you're an expert in computer graphics and like that's why we want to hire you, you're probably going to keep coding in C++. Or if you're like an iOS expert, then you're going to come and still be writing in like Objective-C or whatever. But I think more commonly, especially for new grads, it's definitely not a guarantee that you'll be writing in the same language once you get hired because we kind of expect you to be able to learn a lot on the job. And if you don't know the language that you're going to end up writing in very well at the beginning, that's totally fine. We don't expect you to. We expect that there will be a learning curve. So like when I started, I was writing, I now do mostly like Java and JavaScript, and I hadn't written Java in like 3 years, and I didn't remember anything, and I'd never written JavaScript, and it was totally fine. So, yeah, like don't worry about it too much.
Yeah, I would also add that there is a team matching process after you get hired, and you can say, I'd love to work on a team that does Python or Objective-C, even though you did your interview in Java. No one's gonna think that's odd. There was another question? Yeah. For the phone interview, you're using a shared Google Doc. So you're writing and they're actually watching you actively write the code. And then in the on-site, you're going to be at a whiteboard and both of you can see it. But no, definitely the phone interview, it's kind of crazy. You're sitting there watching someone like define their functions, and you can see, oh, these people like to do their brackets first and then fill in. This person, starts one bracket and then maybe never finishes it, or you see those small bits, or who's copy pasting everything to like keep the right syntax. Yeah, but anyway, yes, they see what you're doing in real time.
Not too much. Like, don't start too low because you'll run out of space. Don't write too tiny because I need to be able to read it. That's pretty much it. I don't know. Do you have anything?
The space is definitely the biggest gotcha.
Yeah.
So, like, when you write the code, would you recommend also writing out, like, the memory as well?
Um,
You're trying to explain the code, like, okay, this is in global, and now we're going into global memory. Like, would that,
that's probably, I would say not unless, like, they asked for that. Sometimes, I mean, when you're, like, testing the code at the end, it might be useful to say, like, write out what the different variables are and what their values are and, like, update those as you're going through. But, like, that kind of low-level detail I don't think would be expected.
Yeah, in the corner? I don't know if there's one biggest challenge, right? There are all sorts of things that get in the way. I think nerves though really play into everything. And the only way to overcome that is, I think, a lot of practice.
Yeah.
And meditation or something. But practice and then self-confidence. You could try power posing. I don't know if you guys watch that TED Talk, stand like this and you walk in. And trying to, I would actually say another way to combat nerves is to engage your interviewer in conversation, right? If you sort of have this silent, scary person who's judging you, it makes you uncomfortable. But if you have a conversation and if it becomes more of a dialogue, maybe it can feel more like chatting with a peer or a professor. Yeah.
Yeah, that's good. The other thing is just keep in mind that, like, you don't have to perform perfectly on all of the interviews to get hired. Like, the reason that you do 5 when you come on site is because, like, we know that you might get nervous in some, or it might just be bad luck with another. So also just, like, if you feel like you did poorly on one interview, try not to, like, bring it with you the rest of the day. Like, it'll be okay. Just, like, move on to the next one. Any other questions? Oh, yeah.
Does the work environment is more like a routine or like enterprise environment? Like, describe your daily duties.
I'm not sure exactly how to answer that. Are you asking about the split between like meetings and coding?
Yeah, like,
Is your day monotonous? Every day. That's what he wants to know.
I think it varies a lot.
It depends really if you're on a team that's building something new or making something that exists better, right? And it's also different levels of fear. Like working on search, you can't break search, right? Every change you make needs to be very, very, very thoroughly tested, and when you make that change, it's going to be seen by billions of people instantly. So the first change I make, it gets a million queries a day, but it took me 2 months of testing vigorously before I was able to submit. So I think that's more on the routine side, right? But very high impact. The teams where they can kind of iterate and say, we'll add testing next week. We really want to get this out now. Those are the newer feature teams. And they're talking on the order of like 2,000 impressions a day or something. So if it's broken for 2,000 people, whereas, I mean, other startups, 2,000 is like their highest level. So even the most entrepreneurial feeling at Google is still really high reach, but it's all on the scale of billions versus thousands.
Yeah, there are definitely some teams that are like doing really new or really kind of experimental stuff that operate like startups. Like they move really fast. They don't really care if they break stuff. They don't write tests sometimes, maybe. But search is like kind of the opposite. Like there are lots of processes in place to make sure nothing gets broken. So it's like kind of a balance because things can take longer, but you're also more confident about it and it gets seen by more people. So I think it's kind of like personal preference, and there's enough diversity in the projects that you can find the environment that you work best in.
All right, well, we do have a practice interview question, so you should all think about other things you want to ask because we have plenty of time, but I think we should walk through this practice to give a sense of the type of a question you might see.
All right, so here's the question. Given a 4x4 grid of letters and a dictionary, find all the words from the dictionary that can be formed in the grid.
Does anyone have any initial thoughts or questions about this question? Questions about the question. Problem. Questions about the problem. So in case anyone missed it, what is the requirement of time complexity? It's a great question, and I would say there is no requirement other than as good as it can be.
Yeah, I would say typically there isn't going to be a hard rule, like a requirement that you have to meet. Usually it's like first just come up with something that works, and then if it's slow, try to make it better. All right, well.
Does the next slide have the actual grid?
No, the next slide is a gotcha.
Oh, okay.
So we were hoping that someone would make mistake number 1, but no one made mistake number 1. Mistake number 1 is don't immediately start coding when you see the problem. Don't just say like, oh, I know this is the way to do it. I'm just going to start solving it.
That's counterintuitive, right? You'd think the coolest thing you can do is walk right up to the board and just start going at it. But that is a red flag in a lot of cases.
Yeah.
Well, why is this bad? Do you want to? You can.
Yeah, sure. So, well, like we were saying before, it's like part of the goal of the interview is to see how well you write code, but another really important goal is just seeing how you think about a problem. So we want to see you thinking critically about what you're going to do, like weighing the options, thinking about pros and cons, rather than just like picking something and diving right in. Because it also, like, it might not be right, and then you've invested all this time getting down the path that isn't right. And it's also, like, it's harder for us to help you if you just start coding right away and we don't really know what your approach is. So it's usually better if you can discuss with us what you're planning to do. Say, like, oh, well, I'm thinking that this might be a good case to use this kind of algorithm, and maybe I'd start by doing this, and then I do that, and we can say, like, oh, yeah, that makes sense to me. So usually it'll be a discussion first, and once it's like kind of clear that you're on the right path, then you should start writing code.
You don't really want to take your interviewer down like a roller coaster, right? Where they think you're going in a crazy bad direction, and they spend 40 minutes thinking you're just crazy, and at the very end you say, "Ta-da, it works," and maybe it does, but that they spent 40 minutes being really concerned about you instead of in the initial like starting it out saying, "Here's my plan, bear with me," and then they'll be, I think, much more receptive.
Yeah. It also kind of goes back to the point about communication. Like, as for the interviewer, it's a lot easier for them to assess what's going on if you communicate what you're planning to do and how you're going to do it instead of just doing it.
All right, mistake number
Cool.
2.
Mistake number 2 is not running through an example. So it's usually a good strategy to, like, when the problem is first presented to you, then come up with a representative example for the problem and test out how your proposed solution would work on that example. And that gives you confidence that your solution is a good one to pursue.
I would also suggest this, you don't even need to have a solution. To help you understand the problem, doing an example is great too. I remember one of my interviews at Google, they sort of drew this blob, and they said, design an algorithm that would help this blob like extend only in these 2 directions. It was very visual, and there was the word blob, and I had no idea what they really wanted from me. And so I took I was like, so you want the blob to go here? And they said exactly. And so that's a type of example to help you understand even what you're trying to do. Like in this case with the 4x4 grid, just seeing that sentence means nothing to me, right? So I would love to draw the example and say, so if I started here, I would want this and this, or just this. So really just talking through to understand what you're trying to do in the first place.
Often the first step is actually like making sure you're on the same page about what a solution would be. So, you know, given just this question, there are some things that aren't really clear. So you might want to draw the grid and then say like, okay, so what if I started here? Would it be valid to move diagonally and form a word that way? And then we could say, yeah, that's fine. But it would be hard to have a conversation like that if you didn't, draw it out.
But don't waste the entire interview. That is a good red flag.
Yeah, you do still need to write some code at the end of the day. So, which brings us to number 3. You have to write some code. So yeah, it's not okay to just write pseudocode. It's okay to maybe like start out that way when you're just talking about what your solution is, but you do need to write like actual code that works. Yeah, so a good strategy sometimes is like writing a helper function. So if, I don't know, I can't think of an example.
So one case would be if you were trying to move the blob, right, in this function. And so maybe during the move blob step, I would say, and I'm going to add a function later that is check if this is a valid move, right? So I would write the header for that, and I would sort of say the parameters I'm going to pass, and then I would write somewhere else on the whiteboard the stub, just the header, check if valid move, right? Returns true given this and the set of rules or something. Just so it's clear that I am planning one day to implement this. I know that's not a built-in util in Java I can call check if valid move or whatever, but it lets you also get the real architecture of what you're trying to do done without getting lost all the way in the weeds, right? Because I would say it's really important not to kind of leave all your things half finished as you're going all the way down to implement the very most basic part of your code. Getting your solution and then implementing the methods as they come is a better way to keep your interviewer involved and make sure you actually did the right thing, but still prove that you know what coding looks like and how to use methods.
Yeah, so sometimes there'll be like little pieces of the solution, like moving the blob, that isn't actually like the interesting part of the problem. You need to do it to get the solution to work, but it's like just kind of boilerplatey. So for stuff like that, it's reasonable to just like say, this is the function that I would write, and then later if you have time you can go back and actually fill it out. But it's more important to do like the core algorithm of the solution.
Yeah.
Number 4, force-fitting a solution. So um, something people do a lot, especially like straight out of school, is to just try to like pick something that you learned in class and apply it to this problem, even if it doesn't really fit. So don't expect that like the solution to the problem is just going to be something straight out of a book. We want to see like how you think in a new situation. So you should be, thinking about like practice problems are useful, but you should be able to be flexible with them and not just implement something exactly as you've seen it before.
I would also say, especially as you're an older or higher level student, a lot of the algorithms you're going to be asked to do in this interview are so much easier than the things you're doing in class. Like really, the hardest algorithm I had to do, I could probably have done after my second CS class because it was like sorting or something. But by senior year, you're taking all these crazy complex things and, yeah, I think I want to implement Dijkstra's shortest path so I can solve this graph. Like, no, don't do that. Just do a for loop and it might actually work better. So you're at a huge risk of overcomplicating it if you're only thinking of what you learned last week and not what you did freshman year.
Yeah, generally, start simple and then make it more complicated if it needs to be, but don't just try to apply the most like complicated, impressive algorithm right from the beginning.
Right, it's not actually as impressive because we all know what you're doing.
Yeah, so optimization is kind of a gotcha. Sometimes you like worry too early about doing the most efficient solution, and you end up not actually getting to a solution because you're too worried about making it perfect right from the beginning. So it's, as we've said, it's much better to get something that works than to get something that is really fast but doesn't solve the problem.
And it does show that you're being analytical, right? To sort of say, I know that this isn't the best, but I'm going to do it, and we can come back and make it better later. That actually shows that you're aware of what you're up to. Some people are afraid that if they write 3 for loops in a row, we're going to instantly say, oh, they can't work at Google. But no, that's fine. Just tell us that you don't think it's the best thing in the world and you want to come back later. Yeah. And it also then sets you up for a very nice arc of your story, right? To say, I started out and it wasn't good, and then I made it better and better, and look at me, I'm such a good engineer.
Cool. So picking the right data structure at the beginning is important. And it's good to talk about that. Like, say, I think this data structure would be good for this problem for these reasons. Because if you pick the wrong one from the beginning and then, are really stuck on it, it could mess you up down the line.
But really, these data structures, like arrays, they're very simple things. Don't stress about the things that you learn in your most highly advanced CS classes. That's not what you're going to be using.
Yeah,
most of the
I
time.
mean, most often, you can start with like a map, and it'll get the job done. But so same thing. Start simple, get more complex if the problem actually calls for that. Cool. So back to the problem. Here's the actual grid that you're being given. Maybe the interviewer drew this for you or you drew it yourself. You're provided a dictionary of valid words, and you have to find all of the words that can be made in this grid.
So after we've gone through a few of the gotchas, let's start over. Let's say that this is what your interviewer gave you. Does anyone have any questions or ideas they would like to start with? Yeah.
There's no limitation. It's as many as possible.
Any other thoughts or questions? Yeah. So the question was, which way can you move, right? Top, bottom, left, right, diagonal. And the answer is you can move any adjacent letter, top, left, right, or diagonal.
So here's an example. Yeah, so you can move in any direction. I guess the only constraint is that you can't repeat a letter, so you can't like go back, and it has to be adjacent to the letter that you're on.
Any more questions? Any more thoughts? Okay, so I heard you want to do some sort of search algorithm to generate all the combinations and then take those combinations and verify them with a hash map. Okay, so that was your proposed, and then you also asked a question, is that the right kind of verbalization? I think that's a pretty good way to sort of say what you would do and then your overall plan, and then of course I think the follow-up is, so what search algorithm? And then we can go further. Okay, so we heard breadth first search as an algorithm that you're throwing out. Very cool.
Cool.
We have another point. So depth first. If anyone heard that? What do we think? So we've heard. Oh yeah, one more.
I think I would go with a variable of string that's gonna go scanning all the text and make sure that it doesn't repeat through any statement, and it's just like a text scanning.
Okay, and text scanning. Okay. I think we should go back to the idea of this search algorithm. So we've heard breadth and depth. Do we have anyone who wants to sort of offer some pros or cons of either of those algorithms? Yeah, sure. Okay, so we heard that breadth first will get every combination necessary. Depth first might not, because it might get sort of stuck down some. All right, do we have anyone agree, disagree? Any other thoughts? Do we all know what these two algorithms are? Who knows breadth first search? Who has taken a class and learned that term? 1, 2, okay. So we are talking in gibberish for a lot of people, I'm sorry. And depth first, I'm assuming, is like the same, only a small number. Do you want to give a lecture on what those two algorithms are? I don't think so.
What time is it?
It's just about 11, so we have half an hour. So we should go pretty quick. Okay, next slide, right?
So yeah, something that no one asked was, what is a dictionary? How is that given to you? It's a pretty important part of the problem. You're going to need to use it. So some clarification on that. You can assume that this dictionary we gave you is an object, and it has a method isWord that takes in a string and returns true or false, whether the word is a valid word or not. Okay, so one useful way to approach this problem is, before like trying to jump immediately to an algorithm that you learned in class, just like, how would you solve this as a human? So like, probably the instinctive thing to do is just like pick a letter, go see where you can go from there. If you've made a word, save it to some set of all the words that you've found. And you're probably going to need to do that starting at each letter in the grid as the starting letter, right? Should we talk about like DFS and BFS?
Next slide, I don't know.
Okay.
Maybe. Okay, so the two algorithms that were brought up are actually on the slides. They're both really intuitive and good ways to think about this problem, because this grid makes most sense if you approach it like a graph, right, where there are all these connected nodes that you can transfer to. And the two algorithms that were mentioned here, breadth first and depth first search, are both actually applicable. We think depth first is faster and slightly more intuitive. Personally, it makes sense to me to sort of just go down one letter's path as far as you can to see if it's going to work out, and then try to go the other way. But we're not actually going to give a lecture on those two algorithms. I think you'll all get there in school, and when you do, say, all right, that mock interview workshop that one time. Breadth first search, now I know.
Yeah, so once you've had that lecture, come back. Take
Come
another look at
back
this
and
problem.
try it again.
I guess we could say, like, in this case, we're going to go with depth first search, which is like going down a path from wherever. So if you started at the B, then I could move to A, and then instead of seeing also trying to move to N and also trying to move to L, just staying down the same path and going like as deep down that path as I can go, while testing if the words are valid. It's kind of the intuition.
So we sort of brought this up already. You shouldn't reuse letters, and if your interviewer hadn't been nice enough to highlight this, then you would, no, I mean, you were a good interviewer. Then you might find yourself talking about this when you're going through the implementation of your algorithm, thinking, oh wait, do I need to check the previous letter? Am I allowed to do that? And then you sort of ask a clarifying question, and if the interviewer says, no, you can't return to a letter, then you need to incorporate that into your solution.
So in this case, because we can't reuse letters, we're going to have to do something in our algorithm to mark the letters that we've seen so we know that we can't use them again as we're exploring the new words. Cool.
So this is some sample code here with this idea of laying out the functions you plan to build, maybe talking about them, but you could start with just this and say, here's where I'm gonna begin, and see if that is logical to the interviewer.
So there's some points to call out on this slide. The first comment here is about importing stuff. So you should ask your interviewer, do I need to worry about importing these utilities, these libraries, that kind of thing? Can I use this library? Or do I need to write the function myself? It's always good to check with the interviewer for those things before you just assume and do it.
Generally, most interviewers will say, oh, that doesn't matter, don't worry about it. But the fact that you asked shows that you're really aware of what it takes to code in this language, right? In Java, if you start using a library you haven't imported, they're going to say, where did that come from? Maybe they will. Or maybe you'll say, by the way, I'm assuming I already imported this stuff. So just having this conversation shows that you really know your language, you know what you're up to.
So it's kind of similarly the boilerplate, like if you're making a new object in Java, you could ask, do I need to write out all of the, variable initializing? They might say, oh, don't worry about it. I know what you would do. Or they might say, yes, you need to do it. So it's good to ask.
So if you look at what we have here, there are two functions, find words and recursively find words. Does anyone have any idea what they would do in these two functions, what the point might be? Yeah. I'm sorry, what?
You're gonna look for the text between brackets in here. If you usually find the words, you're gonna find the words.
I think that.
Am I correct? I'm not sure.
I think.
It might be easier if we actually have pseudocode. I'm realizing now, trying to guess what a person is going to do is not a valuable explanation. So wait, let's go to the next function, or the next slide. Here's find words.
So we'll let you guys look at this for a little bit, and then maybe someone could explain what they think is happening in this code. And you might not know Python. So.
Yeah, the syntax, for example, I don't know what xrange does, but I'm assuming it, does what you'd expect. Right?
Okay, does anyone have thoughts about what's happening here? Yeah. Sort of. So actually the first two parts here, the for x in length word grid use.append, that's actually just initializing the data structures that we're going to have. So here, x and y can be thought of as the rows and columns of the grid. So we're going through each row and initializing an array for that, and then going through and initializing the value of used, which is an array that we're going to keep track of which letters have been used. So we're just creating the data structures that we're going to be using, initializing everything to false at first because we haven't used any of the letters yet. So then words is where we're going to keep track of all of the valid words that we've found so far. So after we've initialized everything, this isn't, over there, okay. Yeah, after we've initialized everything, then we're going to go through again and starting at each letter in the grid, call our magic recursively find words function, which we haven't implemented yet, but we're going to assume finds all of the words that start at that letter. And then whatever that returns to us, we're going to add to our words set of all of the valid words that we've found. And then at the end, we're going to return that.
So basically, this is the step that nobody even thought was worth talking about out loud when you looked at the problem, right? This is not the hard thing. This is the obvious we're going to have to go through and then do something hard. So, but even getting to this step to say, here's how you would iterate through a two-dimensional array is some valid stuff that you need to demonstrate you can do. And then very clearly saying, recursively find words is this hard function. We're going to have to write it in the follow-up. But being able to do this, and you can see how fast someone knows, okay, two-dimensional, x, y, boom, 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 here we go. That sets a really good stage of confidence in the candidate of being able to deal with, arrays as a data structure.
Yeah, so like we said earlier, there's kind of separate focuses on coding skills and algorithm skills. So, this part is kind of like the coding skills, like can you iterate through an array? Can you write working code that does that? Can you do it, quickly without getting like really stuck on stuff? And then the recursively finds words part is more of the algorithmic side. That's more of the like complex part. Okay, so here's an implementation of recursively find words.
Take a minute, take it in, admire the beauty of all of those letters on a screen. So silly.
So does anyone have any idea what all of these if statements are checking? Yeah. So it's checking what?
It's checking the repeating of every character and it's building the structure of the 6.
Right, so it's checking all of the letters around the one that we're on currently. So each one, the one above me, the one above and to the right diagonally, the one directly to the right, is checking all of those and checking if it's been used yet, and then adding it to our word, and going from there.
And this is not completely obvious, right? I know there are a lot of ifs, and your first thought is like, oh my gosh, but you have to check the edge of the array that you're on, right? If x minus 1 is greater than or equal to 0, that might have been a gotcha that someone just sort of said, oh, well, obviously we go 1 to the left and then 1 up. But really, you could be on a corner, and that's an edge case you have to be aware of. And then checking that it hasn't already been visited is a really important step. So there are two things happening in each of these ifs. And I'm sure there would be a candidate out there that wouldn't have checked one of those two.
Yeah. And I mean, if you didn't think to check that you're going outside the bounds on your first time writing it, that's okay. Hopefully you would go through an example and figure out like, oh no, I'm having I'm trying to do like -1 index into this array, and then you'd say, oops, I need to check this and add it in. Cool.
Exactly.
Does anyone have any, criticisms about this code? Mm-hmm.
Because like each lines to also each kind of like direction can be its own function, so you only have the declaration like move wish. So basically like each if statement can be encapsulated in one function. So so basically when you read through it, you can see it like an algorithm, and then you kind of
So for everyone that didn't hear, I think the suggestion is define a function, move left up, move up, move right up. So when you're looking at it, it's very, very clear exactly what you're doing. And that is a really solid point, especially when you're thinking of, general programming skills for writing code that someone else is going to read down the line. That's a good idea for naming and for clarity.
That would definitely be an improvement to this mass of words. So I think the really important point that you made is that this is really hard to read. It's really hard to like parse and figure out what's actually going on. And that's important, especially in an interview where it's a limited amount of time and the interviewer needs to like be able to figure out what you're doing.
I would also say if you are doing this in an interview, you get this question and you know that you're about to do the same thing 8 different times because there are 8 positions, it's worth really going through the implementation of maybe 1 or 2 of those positions and then turn to your interviewer and say, I would do the same thing 6 more times. Do you want me to write it out exactly? Or maybe you could say, because I'm about to do the same thing 8 times, there might be a way I could write a function to do this for me. I'm going to try to improve this instead of spending the next half an hour writing out all of these words. So if you're going to do the same thing a lot, first off say, I'm only going to implement once. Do you mind if I stop now? And then maybe put your energy into improving the algorithm as a whole.
Good point.
Which maybe could be done with our next slide. Ta-da!
Look how much nicer this is.
So here basically we are just, instead of actually going through every specific combination of X and Y's that create your left and your diagonal and your up and your down, we're actually just going to define ranges and recursively go through those ranges and then call recursively find words with the new value you're at. Yeah, I think at this point we should probably stop and do more questions. The exact solution of this algorithm is not the important part of interviewing. What's important is the process that we've sort of gone through here of trying to illustrate how you could start with a brute force and make it better and ask clarifying questions and go through examples. So I think we have the last slide that is the...
All right. So important thing to test it, make sure it works, go through the complexity, and then, if there's time, you could talk about what you would do to make it better, kind of like debrief afterwards, like, oh, I made this decision. In retrospect, maybe it would have been better to do it this way, or if I had more time, I would make this adjustment.
I totally fell for the first one, though. I said, okay, we're done. See you later, instead of doing an example. Oh, there is a question right here.
Okay. Yeah, let's go to questions. Maximum?
Okay.
I think the goal is to just find as many words, find all of the valid words. So every possible valid word in this grid is the goal.
Yeah, 4-letter is just this example, and it is also Boggle, right? So we're all familiar with those rules. But yeah, everything. Find them all. But I'm sure at some point, your interviewer, if they saw you were like adding, a character limit to the word count, right? And checking if, less than or equal to 4 added to the thing, they would say, why are you adding the 4 there? And you'd say, because
Yeah.
it's 4-letter words, obviously. And at that point, they might say, no, it's all of them. And then you would just simply erase that line and, move on. And you still would have had a great solution, and you would have responded to their feedback, and that, yeah.
Yeah, as we said, like, your interviewer is there to help you do the best. So if they notice something like that, they're going to call it out and ask, like, what are you thinking about this? And try to, like, move you onto the right path. And like, an important part of the interview is how you respond to their feedback. So, if you incorporate their feedback and adjust to it well, then it's actually a really good sign.
Don't take that to mean every time someone asks you a question, it's because you're doing something very wrong.
True.
Right? And that also can trip you up, right? If someone says, wow, like, why are you using that thing? You might say, oh gosh, I'm doing the wrong thing. Oh, no, this is the worst ever. But they might just be really intrigued because it's a way they haven't thought of before, and they're genuinely curious and excited about what you're doing. Or it's because you're doing something wrong. So but
Yeah,
there is a positive way to take that as well.
It's a really good point, because there's never just one way to solve a problem. So if your interviewer asks a question like that, it might just mean, they're interested. And that's a good way to turn it into a discussion, which is also good.
We should probably go back to the last slide and see if we didn't cover any points. Take a picture of this, think about it when you're at home. And then beyond that, is it just questions time? Maybe.
So I guess this is an example of, like, sometimes if you finish the problem and there's still time left over, your interviewer might ask you a follow-up question to make it harder. Like this, what if the grid is too large to fit in memory? And sometimes, like, there's only a few minutes left in the interview at that point, so it'll just be to talk about it. Like, they won't expect you to actually write another solution for that. It's just like an ongoing discussion as a follow-up. Okay, yeah, so we don't expect you to, get everything exactly perfectly right. We know you're a human and not a compiler, so don't get really stressed out about, like, oh, I forgot a semicolon, now I'm never going to get the job. That's not how it works. But, try as best as you can to write code that would run. Yeah, and then just more points about, like, make it as easy for the interviewer to read as possible.
The point about inserted code, this is really only important on a whiteboard, because when you're in a Google Doc, you could easily just add some lines and add a check at the front of your function if you forgot it. But on the whiteboard, if you realize, oh no, I needed to do this thing in the very, very start, don't erase everything you've already written. Just draw a little caret sign and then write the content somewhere else, because there's nothing more useless than rewriting something in an interview.
Yeah, so we expect that to happen. It's totally fine. Yeah, so we've gotten to the end. Just remember, practice, practice, practice. It helps see what kinds of problems you can get, and it helps you be more confident, which is really important.
Yeah, are there any more questions now about anything we've talked about, anything not related to interviewing, if you just want to know more about, life at Google, or, I don't know, our favorite TV show? Yes.
I was wondering if you could recommend any, like you mentioned books earlier. I know I wrote it down in Facebook already, but the things that you've read that were impactful in your career, like how you, and more about you too, like how you got, I know that you did instructions before, but some of your personal interests that maybe align with tech, or don't. Just curious how you got involved here.
Do you want to go first or should
I'm happy to go first. So first off, books. Cracking the Coding Interview is the most ubiquitous, and it's a really great resource. I would actually say, in addition to books, there are lots of websites where you can sort of Google technical you can go on your favorite search engine and ask technical interview questions, samples, or practice resources, and sometimes you can just see lists and lists of like X interview questions that companies are no longer using because they're too well known, but at one point they were used. So doing that as a practicing resource, and then reading books to get me more interested in the technology space. I don't know if I've read too much. I read plenty, but it's all fiction. I read Lean In by Sheryl Sandberg. I highly recommend if you guys haven't, especially for the college grads. It's really good. It's just, yeah, I'm a fan. And then also the Steve Jobs memoir is my only other kind of technical
Yeah, it is really
interest, tech scene. Personally, I went to Amherst College, which is out in Massachusetts, and it's a really small liberal arts school. And I came in wanting to do neuroscience. I had no interest in computers or computer science as a skill set. But my freshman fall, instead of taking a calculus class, I decided I would do something slightly more out of the box that I had no experience with, and that happened to be Java 101. And I fell totally in love and ended up doing computer science as well as my biochem. So I have the science, and I'm still really interested in it. But for now, I'm working Google software engineering.
Yeah, so I don't really have any other books to add, honestly, but I also didn't go in really doing computer science, but I did a like computer graphics program that I got into more because I was interested in art. So like I did a lot of art in high school and math, but I didn't know anything about computers. So I wanted a way to like do those together. So I did this computer graphics program, and I was like, well, hopefully the computer things will be okay. And I ended up liking it a lot. And now here at Google, I'm a like UI front end engineer. So I mean, my day to day is still developing, writing code, that kind of thing, but the arts background is really useful in like making UIs and design and that kind of stuff. So there's a lot of different ways that you can get into computer science. It's a very wide field, so there's ways to like incorporate your other interests into whatever project you're working on.
Any other questions? Did you say you've heard that Google is starting to do more of that, or? So Google wants to hire cool, nice, smart people, right? And if on your resume it says, "Look at me, I'm super smart, I have all this experience, but my hobbies include like watching TV every single night," that's cool and smart. But if your resume instead says, "I watch TV 6 out of the 7 nights, the last night I volunteer," that's way cooler and way nicer. So I don't think you're going to get rejected if you don't have Greenpeace on your resume, but it's definitely a really good point to prove that you are more than just someone who writes good code.
Yeah, I would say in general, like the people that work at Google tend to be very like well-rounded and have a range of interests.
Yeah.
And we have a lot of stuff going on at the company, like we have volunteer programs through work. Like you can, you're allowed to like spend, I don't remember exactly, some number of hours doing volunteer work like as work time. And we do like outreach with the community and all that kind of stuff.
Was there any more questions? We have probably time for 2 more. Here, actually, you haven't spoken yet. Lean in, yeah. All right, do you want to go?
Actually, I'm also switching from another major. What's your biggest challenge when you actually go into like a real world working environment? Like, because you guys, it seems like you guys are from another background, and now you are studying coding. So, what's the biggest challenge when switching?
Yeah, so I definitely, because I had like more of an unconventional undergrad, had some gaps in my knowledge. Like I never took a operating systems class. I never took a compilers class. So, I mean, for me, I just kind of know that there are some things I don't know as much about, and if I ever come in contact with those in the real world, I'm probably gonna have to like do some extra homework to get up to speed. But you know, it's nothing you can't learn on your own.
All right, so I think we are running out of time. There are a lot of people coming in. So thank you guys for listening to us.